The next presentation would be on the Japanese Thorium program by Dr. Toshinobu Sasa. Dr. Sasa is from J-Park Center of the Japanese Atomic Energy Agency. Dr. Sasa.
I should only research. I understand, but okay. So, thank you, Dr. Chairman, ladies and gentlemen. It's my honor to be here to show the Japanese thorium programs. Actually, the Japan have a strategy based on the uranium and plutonium fuel cycle. So there's not a national Japanese program on thorium on it. At the academic side, we have some programs. I will introduce about this. So today I'd like to introduce the following items: the present status in Japan, and thorium fuel studies in Japan. And also liquid fueled ADS concepts, because I'm from the ADS sector. So also the next review of PT technology. It is extra, but very hot news. So I'd like to introduce about this and summarize my presentations. So this is the present status in Japan. I would like to start the story before the Fukushima. So before the Fukushima accident, we excited about the so-called nuclear renaissance. At that moment, over the half of the electricity demand will be supplied by the nuclear. And also, it is very important to satisfy the Kyoto Protocol. So based on these trends, the Atomic Energy Commission of Japan started to revise the framework of nuclear energy at the 2010s. So however, before going to the Fukushima one, so at the revision of the framework of nuclear energy, the Advisory Committee on Research and Development was summarized the report at 2009. So within this report, the committee recommended to Atomic Energy Commission to make R&D to prepare the future uncertainty. Within these contents, the R&D for direct disposal of spent fuel, interim storage, and application of thorium, and nuclear proliferation resistance, and uranium extraction from seawater. And many other activities should be performed continuously in appropriate level. So, however, the Fukushima occurs. We are very sorry about this, but after just Fukushima, the reduction of nuclear power generation was discussed in a very wide range of within Japan. So, however, the last year, the Liberal Democratic Party won an electoral of the House of Representatives. And after that, this party is still aiming at decreasing nuclear power, but they mentioned utilization of the current nuclear power plant with uranium plutonium fuel cycle for stabilized electricity supply. It is not to be done, and we spend so much money to burn the fossil fuels. But still, the government point of view, it will be planning this. And along to this, new energy policies and the discussion will be summarized within this layer, I think. So, concerning the nuclear waste management, after Fukushima, the people's interest in the management of nuclear waste and management of the spent nuclear fuel itself is very grown up very widely. And method to decide the waste disposal site becomes major issues of nuclear power. So Atomic Energy Commission asked the review of the high-level waste management to Science Council of Japan because of site selection is not progress so good manner. So from the recommendation of the Science Councils, so I'd like to talk the essence of these recommendations. So they requires a fundamental review of the waste disposal policy. And also they recommend to promote a temporal safe storage. It means interim storage in nuclear technical words. And during the interim storage, they recommended to perform the following studies should be enhanced. One is waste transmutation. And the other is the safety of fuel storage and stability of the geological layer. This waste transmutation, they recommended to enhance the research activities. It will be mentioned later about this, about what news I mentioned. So, concerning the thorium fuel studies in Japan. So, at now, I already mentioned there is no national programs, but there is two activities based on the scientist communities. So one is a working group for thorium fuel application in LWR and FPR. This group is focused on the solid type thorium fuels. And the meeting was held 5 times from July to December 2010. It means before the Fukushima accident. This activity is focused on the revision of the nuclear energy frameworks of the nuclear energy. But it is halted by the Fukushima accident. But they summarize some major subjects. The one is characteristics and introduction scenario of thorium-loaded reactors, and also the thorium fuel cycle and properties of the thorium fuel and materials, and public acceptance and licensing of thorium fuel or thorium fuel reactor, and current state of the art of the fuel. They discussing about this and make a summary before the Fukushima accidents. From the summary, the thorium fuel has enough potential to use. And still exist many issues and problems to be solved. A detailed review of the past studies should be done because we have very short time to summarize this. So the important to keep service study of thorium application and point out of the issues and problems should be continued. The work group had been suspended by the Fukushima accident, but now the situation is changed, and the working group will be resumed from next month. Middle of next month, we have the first meetings. So another side of the activity is set up of the research committee for the molten salt fuel. It including, of course, the thorium fuels. So this was set up in Atomic Energy Society of Japan. The mission of the committee is like this: the survey of the molten salt technology for molten salt cooled reactors, molten salt fueled reactors, and also the dry reprocessing process of the molten salt fuel. They aimed at the summarizing the current state of the art and issues. The committee will also start from next month. This is also the started next month. But it is now preparing for some agendas or something. So we have two committees for solid fuel and liquid fuel. And I hope these two groups will be summarized summary within 2 or 3 years. So after that, also I hope the Atomic Energy Society of Japan makes some position papers or something about the thorium fuels. This is my hope. This is not the promised missions. So I briefly introduced about the liquid fuel ADS concept. So this is a very old one. This is not our activities, but the Dr. Furukawa's concept. The accelerator molten salt breeding system. This is used to create uranium-233 from the thorium. So very old concept with 1 GeV, 300 milliliters, like as 80 W speckle, so it's a very high intensity. The fluoride salt is used for as a target and core. And reactor base is made by Hastroy, and the windless target is adapted. So the purpose and performance is when we used this as a weapon-grade protein burner, it can be burned 300 kilograms per year. As used for the uranium-233 breedings, 700 kilograms of the uranium-233 can be made within a year. Uranium concentration is about these values. So this is our concept. There is no specific activities on this. And the second one, this is our studies. It is also very old one. It's about the 1990s concept. Oh, sorry. So this system also using molten salt as a fuel and exploration target. The beam coming from here, 1.5 GeV. And when we set up the K effective is 0.92, the beam power is like these values. So some power is about 800 megawatts. The fuel temperature is like this range. So when we used the primary, we have two choices of the molten salt. One is sodium chloride-based fuel. And the second one is a lead chloride-based one. This is much better for the exploration reactions. But we can use both for these systems. Initial minor oxide loading is about 5 tons of the minor oxide, and we can burn it. 250 kilograms of the minor oxide can be burned annually. So, as the morning sessions, Dr. Rubia said, when we trim the breeding, it can be used to minor oxide burning. It is a vice versa manner. So when we can burn minor oxide, it can be burned. It can be breeding the thorium. So as spare off the minor oxide fuel and pouring this molten salt on our systems and simply burning and by the accelerators. When we set up the K effective of these values, so this is I miscopied this one. This should be uranium-233 loadings. About more than 10 tons of uranium-233 is installed. So the secondary current is this one, and proton beam is 1.536 milliampere nominal. So without any chemical process, the K effective decreasing like this manner, causing accumulating of the fission products and loss of the fissile. So, but still, we have only 4% of the K effective drop during 1,000 days. When we apply the chemical process to this systems, it can be stabilized, I think. So, but I mentioned about it is here. So this initial uranium-233 is very big. That's why the K-effective is so decreased slowly. So this is not suitable for the some systems. So we halted this study at this year period. So we do not considering about, and we focused on the solid fuel during some periods. And several years before, we considering about the fuels, because the minor oxide fuel has a very big heat release, and it is very difficult to manage such heat release, even in fresh fuel. So we considering the liquid type fuel. And at that moment, we remember the old type of the system like this. The most difficult position is here, beam window. Its temperature, fuel temperature is this value. At the beam window temperature exceeds about 700 degrees centigrade. So it is very difficult to last standing these beam windows. So we changed the concept like this. We detach the exploration target and separately cooling by water. And surrounding, we located an annular type tank surrounding the exploration target and circulated liquid fuels inside. So like this manner, we can make much more realistic AD system concept. One of the characteristics applying liquid fuel is reactor locations. In ordinary case, the ADS using a vertical beam injections because of the cooling of the remaining fuels. But in the case of the liquid fuel, we do not need so much care about this. So we put core horizontal and beam injected in horizontal manner. So it is one of the characteristics of our latest concept. So when we make initial K-effective 0.98, the proton energy set to 600 MeV, and proton beam power is about 5 megawatt. It is a very reachable accelerators in current technologies. So reactor power is about 320 megawatt, and we used this for americium transmutation, not the whole minor accident, but americium transmutations. So I'd like to, so this is current activities. There is many other activities for concerning the thorium fueled fast reactors, but there is no presentation here, sorry. So I'd like to mention about the hot news. We made a national review of the PT technologies. So on July 9th, Ministry of Education, Culture, Sports, and Science and Technology of Japan. I'm very long, I'm sorry, we have to recall next. So they launched a review committee to evaluate the current state of the art of the partitioning and transmutations. In fact, this partitioning transmutation technology is started with a certain period of reviews. The last review was done at the 2008 to 2009. So this is a good timing to make some reviews within 4 or 5 years. So in this review, a committee discussed following items. So of course, they discussing about current PT research activities. And also the construction of the ThEC is a transmutation experimental facility that is planning within the framework of the JPAC project. They are discussing about the merit or demerit of the construction of this facility. And also, we committee discussing about the collaboration of the MIRA project. So, report planned to be issued in October 2020. This is end of the October, but in fact, the report was originally, it was issued on 23rd of the October. So it is already summarized, but some problems caused by the typhoon, not the earthquake, was occurred, and the committee meeting is postponed to end of the October. And so the report will be issued on day after tomorrow. So this is a member of the review committee. Many various field of specialists are joining. The Akira Yamaguchi is a chair. It's from the first reactor safety issues. And also many fuel cycle specialists and one neutronics specialist and material specialist and accelerator specialist. And also the economic specialist is gathered in this program. Maybe you know the famous guy here. He's explanation. He made the explanation of the current state of the art. So, you know, the two ways of the minor accidental transmutation exist. One is using for fast reactor. So, discussion started by the former cabinet that is aimed at reducing the nuclear power in rapid speed. So, the next launched the working group for Monja application and using the R&D or PT. This will be also summarized within this year. The another way, using ADS, is discussing in this committee. The current cabinet describes an acceleration of PT research in their manifest and policy index. So next, also launched the working group to realize current state of the PT of ADS. And this summarizing the interim report. This is, I'm sorry, tentative. It will be deleted within this meeting. But the essence of the interim report is listed in here. To realize the partitioning of transmutation, preparation of the facility should be required to handle certain amount of the minor actions. The plan to establish facilities should be continued. So as for the as for the transmutation experimental facility in JPAC project, a step up to the next stage is expected. This is very delicate explanations, but there is no specific plan for budget, so they summarize like this was. They cannot say go on, but they recommended to step up to construction stage. So progress should be reviewed with these 3 years. And as for the participation to MIRA project, comprehensive cooperation is recommended not only by us, but also for universities and commercial sectors. So it is proper to begin negotiations with Belgium. And also the progress of negotiations should be reported to the committee. And also the committee continues the review works for partitioning and transmutation technology and discussing about these progresses. So, I'm sorry, this Mr. Arai. So, I made summaries of my presentations. So, the present status in Japan still stay in uranium-plutonium fuel cycle with LWRs. So, government promotes to restart current nuclear power plants, and also discussion of new energy policy is underway. concerning the thorium fuel cycle studies in Japan, research committee and working group will be started within the framework of the Atomic Energy Society of Japan. The working group for the thorium fuel application in LWFBL suspended due to Fukushima, but it will be restarted soon. And also discuss mainly solid fuel issues. And the research committee on nuclear application of molten salt, it will be discussed the molten salt systems, including dry reprocessing processes. So Atomic Energy Commission also suggested to summarize a reference of the discussion as a specialist point of view. I hope this point of view will be summarized. So the liquid fuel ADS concepts, we have several concepts and proposed from JEA and universities for ADS, for thorium breeding, ADS for minor accident transmutations. So along to this, the transmutation experimental facility for ADS experiments under review work for construction. And it will be approved to step up to next phase. Thank you for your attention.
Thank you for a good presentation about the progress in Japan. I think we are running out of time, so maybe we can take just one question. Kadi.
Hello. Concerning, if you can go back to the ADS, the curve you showed for the thorium uranium breeding with the ADS.
Yes.
So one of the problems you have here is that you are loading 12 tons of uranium-233, so that should correspond to 6% of the molar fraction.
That's right.
And if you compare to the thorium, so you are well above the breeding equilibrium of uranium. So basically what you have there is a uranium burner. Mm-hmm. So for this type of spectrum, you should have less than 10% uranium in thorium, in the fuel. Mm-hmm. So this explains why you have this curve. So your K effective is falling, and you have to compensate by. Mm-hmm. So it's just a question of basically changing the concentration of uranium with respect to thorium, and you would basically achieve a perfect breeder. Thank you. Mm-hmm. So if you look, I mean, that's 12 tons, 6 out of 34 or 40, so that's about 14% mm-hmm. Concentration of uranium. This is too high.
Yeah.
This paper is 10 years old.
Yes. I'm sorry. It's a very old one, but also made by some students. It's very limited knowledge. So we don't, also this is very sensitive for this kind of disease. So I understand your meanings, but anyway, at that moment we choose these values.
I think we are running out of time, so maybe further questions can be discussed during the lunch break. Well, with this, we return our thanks to Dr. Sasa. Thank you.